So we are now going to be adding and subtracting like fractions. A bread recipe calls for 1 1/3 cups of whole wheat flour, 2 1/3 cups of white flour, 1/3 cup of oatmeal, 1/3 cup of apricots, 1/3 cup of hazelnuts, and 1 1/3 cups of warm water. You're going to answer these questions. What is the sum of the whole number parts of the amounts? How many 1/3 cups are there? Add up the 1/3 cups to find out how many total cups there are of the 1/3, and then the total number of cups altogether. Go ahead and answer that, and then check back with me. So I added up all the ones that I circled in red, which were 1, 2, and 1. Added those up, and I got 1 plus 2 plus 1 equals to 4 cups here. And then I added up how many 1/3 cups are there? Well, I circled in blue up there in the question 1, 2, 3, 4, 5, 6 of the things. So there's 6 1/3 cups. And since there's 6 groups of 1/3, I do 6 times 1/3, or I could just do 1/3 plus 1/3 plus 1/3 plus 1/3 6 times, and I end up with 2 cups when I do that. So I take the 4 cups that I had for the whole parts and the 2 cups that I got from all the 1/3, add those up, and I end up with 6 cups of ingredients. All right, so let's draw a model to show the sum of 1/5 and 3/5. I would like you to draw a model and then compare it with mine. There's lots of different ways of drawing a good model for this. So there's lots of ways of creating models. If you haven't figured out by now, I like rectangles. Basically, I made a blue rectangle in here and divided it into 5 parts, into fifths. And then the 1/5 I shaded in red as 1 square of there. And the 3/5 I shaded in green as 1, 2, 3 of those squares. And when I add them together, I ended up with 4 of them. And that's what I have in yellow, showing all 4 of them. And so 1/5 and 3/5 is 4/5. And that is a model that shows that pretty carefully, how the 1/5 and the 3/5 add up to give me the 4/5. All right. Now let's go ahead and do number 3. We're going to be adding some like fractions, okay? Today, starting off in this lesson, we're going to be doing everything with a common denominator. What people tend to have the most trouble with is actually dealing with the negatives. And so this case here, I've got 5/8 plus -7/8. And we have to remember the same rules that we had for integers with negatives and positives are the same rules that we have for fractions as well. So when I look at this, I think I can think of this in one way as like 5/8 of a pile and 7/8 of a whole that are going together. But I prefer, particularly because they already have a common denominator, is just ignore the denominator and think of it as 5 piles and 7 holes. And that means that 5 of my piles are going to fill up 5 of those holes, and there's going to be 2 of the holes left. So I'm going to do a quick little showing of I have 5, 1, 2, 3, 4, 5, and I'm going to have 7, 1, 2, 3, 4, 5, 6, 7 holes from that -7. These guys are all going to fill in. The piles are filling up those holes, and I'm going to be left with 2 holes left, which means I'm going to have -2 as the end. Now, we have to remember that it's still over 8 as the fraction, so my fraction will be -2 over 8. And I can reduce that fraction. They're both divisible by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. And I'm left with -1/4. Okay, so I'm going to ask you to go ahead and do all of the problems for number 4, and then we'll continue with subtraction in a minute. So you need to remember that when we're adding up fractions, the denominator stays the same. So in 4a, we have the denominators are 9. Some people make the mistake of when they see the 9 and the 9 and they add them together to get 18. But the denominator always just stays the same. The 5/9 plus 7/9 is actually, you add the 5 plus 7 to get 12, and the 9 stays as a 9. I'm only changing it to a 3 when I reduce the 12 over 9 to 4 over 3, and then get a mixed fraction. In part B, I've got 5 holes and 1 pile, leaving me with 4 holes, and then I reduce that fraction. And then in C, I have 1 hole and another 5 holes, which gives me 6 holes. And so I got -6 over 6, which is -1. I want to ask you a question about question B in terms of how I'm allowed to write an answer. I wrote there -2/3. what are the ways that I could write that? Can I write that fraction like this with the negative on the top of the fraction? Can I write that same fraction with a negative in the bottom of the fraction? Can I write it in front of the whole fraction like this? Could I write it in a negative in front? So can I write it as negative 2 over negative 3? Which of these, I'm going to ask you a question, which of these is not correct? Please answer that on the Edpuzzle. And you can have more than one answer. Answer all the ones that you think are wrong, that are not equivalent to, are not good to leave as the answer. Which of those are wrong? And the answer is, this is good. Oops. Putting here, this one is fine. This one is fine too, although we don't usually leave the negative in the denominator, but it's certainly equivalent. This one is as well. All of these are the exact, these all mean the same thing, because a negative, in the first one, a negative divided by a positive is a negative. A positive divided by a negative is also a negative. But this last one is a negative divided by a negative. So that one actually turns out to be 2/3. So that one is not correct. That is a positive value. The other ones are all negative and equivalent to negative 2/3. So those are, you could write your answer in any of those three ways. Okay, let's go ahead and do number 5. Number 5 is subtraction, but remember, with integers, I think of this as really the same thing. I have negative 8/9 and I could subtract 7/9, but that actually often confuses people. When I think about wholes and piles, I think of this as 8 wholes. In the first part here, there's a negative 8, which is 8 wholes, and the next one is negative 7, which is another 7 wholes. So I'm going to put those together, and 8 wholes and 7 wholes actually gives me 15 wholes, again, out of 9. And in this case here, I can go ahead and reduce it. These are both divisible by 3. We get 5 and 3, and so, and it's still negative. So I have negative 5/3, which is actually negative 1 and 2/3. Okay. What about 6 here? I've got 3. Now I'm starting to move into some improper ones. How do I add these together here? So I've got 3 and 7/9. I'm going to add 2 and 4/9. Now, unlike multiplying, when I can't do the whole parts and the fractional parts separately, with adding I can. I've got to be careful with subtracting. We'll get to that in a little bit. But if I've got 3 and 2, I'm going to end up with 5 for the whole parts. And the 7/9 and the 4/9, I add those together, and I'm going to end up with 11/9. Now, this is kind of weird because I have a whole number and an improper fraction. There's no way I can leave my answer like that. So I'm going to think of it as 5 plus 11/9, or 11/9, another way of writing that is 1 and 2/9. And then now I can add the whole parts up there. 5 plus 1 is 6, and 2/9 here. Okay, moving on to number 7. 7 is actually a challenging problem here. And I'm going to give you several different ways of thinking about this one. And you can choose which of these models works best for you, but be very careful about this. A lot of people make some mistakes, and I'm going to talk about those as well. So Jasmine is 60 1/4 inches tall. Amber is 58 3/4 inches tall. How much taller is Jasmine than Amber? Show 3 different ways of answering this question. All right, so here we go. I'm going to start off with thinking of it this way here, where I have 60 1/4. And what makes this one challenging, and I'm going to subtract, 58 3/4. So I like writing this vertically as I put it in here. Now, what makes this challenging is 60 minus 58. We can say, oh, that's 2. But the problem, the other one, and actually, maybe so this is actually not a hard thing for people to think about. If I just do the whole parts and I have 60 minus 58, I get 2. But this is what gets challenging here. When I do 1/4 minus 3/4, remember that the smaller one is up top, the smaller fraction. So I have 1 pi. I'm basically taking 1 and subtracting 3. That's actually going to give me a negative 2 in there. So I'm going to get 2, and I'm going to add negative 2/4 to that. Okay, so that gets a little bit confusing. So if I have basically 2 and negative 1/2 that I'm adding to it. So in other words, I'm taking half off of that 2, and I'm going to be ending up with 1.5. So that is one way of finding their difference here. Let me do another way. This one I'm going to do a borrowing method. All right, so the first one was doing the whole and the fractional parts separately, but just being really careful to know what the signs are of these things. Okay, so the next one, I'm going to do this. I'm going to do the same thing, 60 and 1/4 and minus 58 and 3/4. I'm going to set it up like this, but I'm going to realize that, hey, I don't like that 1/4 subtracting the 3/4. I would much rather have a fraction that's bigger than the smaller one. So I'm actually going to borrow from the 60. So I'm going to change the 60 to a 59. I'm going to borrow a whole one, and I'm going to add 4/4, which is a whole one, to the 1/4. So now I'm going to end up with 59, and the 4/4 that I took from which is a 1 that I took from the 60 to make it 59 is going to add to the 1/4. 4/4 plus 1/4 is 5/4. So I'm actually going to have an improper fraction for my top one. And now when I subtract, I'm going to do 59 minus 58 is 1. 5/4 minus 3/4, is going to give me 2/4, which again is 1.5. Okay, so that's another way of doing it. This next method is actually my favorite one. I think this one is the easiest one to make this an easy problem. I'm going to start off again, with 60 and 1/4, and I'm going to have 58 and 3/4. And I realize what makes this one so difficult is that fraction 3/4 in the bottom. If that fraction was gone, then subtracting this would be really easy. So if I look at the 58 and 3/4 and I added 1/4 to it, I'll make sure I have to do that with the other one. If I add 1/4 to both of them, the difference between them is still going to be the same. So 60 and 1/4 plus 1/4 is 60 and 2/4. And 58 and 3/4 plus 1/4 is 4/4. That's a whole one. And that gives me 59. And there's no longer any fraction because there's 4/4 changed into the 1 that added to the 58 to make it 59. And then I'm going to subtract that one. And I get 60 and 2/4 minus 59. I get 1 and 2/4, which is again 1.5. That's actually my favorite one, just because the idea is to get rid of that bottom fraction and to make it really easy to subtract. But I have to remember that whatever I change the bottom one by adding it to, I have to add it to the top one because I'm keeping the difference between those two numbers the same. Okay, the last way I want to show you is with a number line. And so I've written that down here. I've created a number line, and I'm going to put the numbers in here. I've got 60 and 1/4. So I actually put in from 58 to 61, and I put the black marks to do the whole numbers, and I put the red ones to show the quarter differences in between. And so right here, this is 60 and 1/4 is right where I just put that blue dot there. And we're trying to find the difference between that and 58 and 3/4. So I have 58, 1/4, 2/4, 3/4, the third dot here. And I'm going to try to find the difference between them. So starting at 3/4, 58 and 3/4, I know to get to the next 3/4, that is actually a 1. All right, and then I'm going to move another 2/4 to get to the next one. There's 1 and 2/4 that I've moved, which is 1.5. Another way of looking at this one visually to be able to tell. So I've given you 4 different ways of going and finding the difference between two numbers that are not always that easy to find here. And so you can choose which of those that you want to use. So find at least one of those methods, and if you would like, try out a few of those methods, or try them all out and see how many of those methods that you can do to subtract 121 and 2/5 minus 119 and 3/5. Try any of those ways that you've done. See if you can figure out to find the difference between those two numbers, at least one of the ways, and then check with my answers. So here the answer is 1 4/5. And again, I did it 4 different ways for you to check to see hopefully one of the methods that you chose worked for you.